Okay, calculus is broken up into three really big ideas. The first one is a derivative. You do know how to find the derivative, don't you? Yeah, in fact, you've learned the chain rule, the product rule, the quotient rule, all those really cool things. I'm just going to write f prime of x, or I'll write dy over dx. Those are derivatives. We've also learned something about limits. And what's interesting is that limits and derivatives are connected. For example, f prime of x happens to be equal to the limit as h goes to 0, you don't have to write this down, of f of x plus h minus f of x all over h. So that's actually what we do a limit to find a derivative. The last thing that calculus is really about is things called integrals. And we haven't gotten to that point yet. That's where calculus gets even more exciting than it already is, which seems ridiculous that could actually happen, but it does. But today we want to focus back on limits. Okay, so you're kind of like, well, we already did limits. We tested on that. Mr. Gantz, I got an A+ on that test. Yes, you guys did really, really well. But the fact is that there are some more challenging limits that we're going to investigate today and tomorrow that we haven't seen yet. So let's glance at those. Important limits. You guys have learned the following. Limit as x goes to a of f of x is generally f of a. You can simply plug in a. And that's if you have a continuous function. So for example, suppose I had the limit as x goes to 1 of x squared minus 4. Well, all I have to do is just plug in 1. And we get 1 minus 4 is negative 3. Remember those easy days? So this one says the limit is x goes to infinity of x to the n. So suppose you had the limit as x went to infinity of x to the 4th power. Okay? So today we want to consider infinite limits. If you look at the graph of x to the 4th, it looks like this. So as x heads towards infinity, what does y do? It heads towards infinity as well. That isn't always the case. For example, let's consider the limit as x goes towards negative infinity. So I'll consider two graphs. I'll consider x to the 4th and I'll consider x to the 3rd. The graph of x to the 4th looks like this, whereas the graph of x cubed looks like that. So if x is trending towards negative infinity, am I headed to the left or the right? I'm headed to the left. And as you head to the left, what happens to the y values? Yeah, you, in this case, would get infinity. But in this situation, as you head towards the left, what does the y value do? Yeah, how come? Because if you cube a negative, it's going to become negative. If you take a negative to the 4th power, it's going to become positive. Okay? So as we head towards positive infinity, negative infinity, different things happen. So there's just a little bit of information there. What about this? X goes to infinity of 1 over x to the n. Suppose we had the limit as x goes to infinity of 1 over x to the 4th. What's going to happen to the bottom as we plug in ridiculously large numbers? The bottom is going to get really, 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 really big, right? And what is 1 over a very large number? It's going to be a very small number. So what do you think this is going to trend towards? 0. Very good. Suppose we had a similar situation. We did the limit as x goes to infinity. We will, but we're going to go towards negative infinity this time. We'll say 1 over x cubed. What's going to happen as you plug in really large negative numbers and cube them? You're going to get really big negative numbers, right? What's 1 over a really, really big negative number? A really small negative number, right? Which is still getting really close towards 0. And that's probably the most important part of the day, is that you understand that 1 over a very large number will produce 0, whether it's positive or whether it's negative. Fair enough? Okay, let's look at this one. Limit of sine of x as x goes towards positive or negative infinity. Hard to plug something in. Let's think about the graph of sine of x. What does it look like? Yeah, it's a wave. Looks like this, right? So as I head towards positive infinity, this wave continues to bounce back and forth between 1 and negative 1, doesn't it? Will it ever settle in on just one number? No. And how about if we head towards negative infinity? It'll continue to bounce back and forth. So this limit does not exist. What's that? Yes. Yes. Yeah. Now, some people say, well, Mr. Gens, does that mean that anything that has a trigonometric function like sine, it will just be does not exist? And hopefully you guys know well enough now that these always statements, they don't really work. In fact, in this situation, it's very interesting. What is the sine of 0 if you were to plug in 0? Sine of 0 is 0. And then if you plug in 0 to the bottom, you get, and we recall that if you get 0 over 0, that's what we call an indeterminate value. And you're going to learn later on this week that in this situation, it actually comes out to be 1. And so you're like, okay, it's going to be does not exist or it's going to be 1. Actually, no. Look at this situation. We're going to let x go to infinity. So you would have the sine of, what's 1 over a really large number? A really small number. So it's going to head towards 0. And what would the sine of 0 be? 0. Very good. We have to go over that again. We definitely did a trig review at one point, but we've forgotten it. So if we look at a 0-degree angle, which would be there, what's that terminal point? 0, 1, or 1, 0? Which one is it? 1, 0. So cosine is the x value and sine is the y value. So therefore the sine of 0 is 0. The sine of 90 degrees, or the sine of pi over 2, is 1. Because you have the coordinate 0, 1, and sine is the y value. What is the cosine of 0? 1. What's the cosine of pi over 2? 0. Okay, so we got that. Good. All right, so let's try some examples. It says, use the knowledge of limits to confirm the following limits algebraically. So what we'd like to see you do is be able to determine these limits and confirm them in an algebraic fashion. So if you just write down an answer on the test, that's not quite sufficient, but you can think about the graph. So let's think about it, and then let's show that it actually happens. What does the graph of 4x minus 1 look like? Looks like that, right? As x goes towards infinity, what happens to y? So you know that the limit is going to be infinity. Here's how we show it algebraically. What we're going to do is we're going to take the largest x term, okay, x, and we're going to factor it out. So we get the limit as x goes towards infinity of x times, what remains if we factor out x? 4 minus 1 over x. Everybody wrap their brain around that that is the factored form. Okay? So you don't have to write this on the test, but I do want to show you that we don't plug in infinity like a number because infinity is not a number. It's a concept. As soon as you say infinity is like, the largest number, well, there's a number after that. You just have to add 1 to it. So I'm going to plug in a very large number for x times 4 minus 1 over a very large number. What is 1 over a very large number going to go to? It's going to tend towards 0. So here you end up with 4 times a very large number. What are you going to get if you take 4 times a really large number? Another really large number. So you're going to go towards infinity. And although that maybe looks like ridiculous math that we just make up, that's a very acceptable way of expressing that. Okay? Okay. So x times 1 over x is 1. So I factored it out of that. So I divided 1 by x. 4x divided by x is 4, and 1 divided by x is 1 over x. Okay, let's do the next one. What are you going to factor out? I factor out x squared. And when you factor out x squared, what are you left with? 1 minus 3 over x. Very good. So as you plug in a very large number, what's going to happen to the 3 over x? That's going to go towards 0, is it not? And so you end up with a very large number squared times 1. What do you get if you take a very large number and square it? Another very large number. So it's going to go towards infinity. What's different about the next one?
Negative.
It's negative. So I'm going to factor out what? I factor out an x squared and you're left with?
1 minus x.
Good. What's going to happen to the 10 over x? It's going to head towards 0. And so we're squaring a really large positive number or a very large negative number. So I'm going to plug in a very large negative number and I will square it. And when you square a very large negative number, it turns to positive. And as you can see, if you were confused about this at all, and people make this mistake on the test, even though I tell them not to, what does the graph of x squared minus 10x look like? A parabola, right side up or upside down. So we can see that whether you're headed towards positive infinity or negative infinity, the y value goes towards positive infinity. So you can think about the graph. Sometimes you don't know what the graph looks like, which would be the next example. We have 2x over x minus 1. We're going to take the common factor out of the top and out of the bottom. Limit as x goes to infinity of x times 2 over, what do you factor out of the bottom? X, and you're left with? Very good. So, when you factor that out, look at what happens. What happens to the x over x? And what is 1 over a very large number? 0. So what are you left with? 2 over 1, which is 2. And that's the limit. What's that? Thank you. Next one. Limit as x tends towards negative infinity. What will you factor out of the top? X cubed, and you are left with? And what can you factor out of the bottom? So hopefully you're kind of seeing what's going on here. What's going to happen to the 1 over x cubed, the 3 over x squared, and the 2 over x? Why are they going to 0? Good. Lots of people answered, and you're right. It's just that people start to memorize processes, and for me, that's where mathematics ends, is when we just start making processes. As we think about what's going on, again, you're plugging a large number. It's becoming even larger when you cube it or square it or anything, and 1 over that will go to 0. So we use that principle of these things going to 0 that I marked off earlier. Will all of these cancel? So what will you be left with in the top? Yeah, just x, right? So these will cancel with, and this will turn to 1. So you just get 4x over 1. Or in other words, 4 times a very large positive number or a very large negative number. Oh, look at that. It's 4 times a very large negative number. So is it going to be positive or negative? So this is headed towards negative infinity. Negative infinity. Try the next one on your own. Go. Okay, I factored out an x squared on the bottom, and notice as I factored out the x squared on the bottom, the top remained 6. Those two pieces went to 0, And as you square a really large negative number, you come up with a really large positive number, and 6 over that should give you 0. Everybody okay with that?
Yeah.
Good. Anybody want to make a guess of what's going to happen with this one? 0, why?
Because the bottom is one much bigger than the other one, so it's going to be a really big number of bottom other than the top.
Good. Can everybody see that the denominator is larger than the numerator? And if the denominator is larger than the numerator, you know it's going to be 0. So on the AP exam, I would not show the work. I would just, they're going to give multiple choice. I would just write 0. As you look at this, can you predict what's going to happen there? It is going to be infinity. Okay? You can think of the shape. How about the last one? Can you predict what's going to happen? Would you agree that the last one's a little bit more challenging?
Yeah.
The last one, the numerator is bigger, right?
Yep.
If the numerator is bigger, it's not going to go towards 0, is it? It will end up going towards positive or towards negative infinity. Let's figure out which one it is. Limit as x goes towards negative infinity of, what do I factor out of the top? So I factor out x squared, you're left with?
5 over
Good. All over, what do I factor out of the bottom? And you're left with? 1 minus 3 over x. So, let's show you how to be very careful, because right now we're rushing a little bit because you're seeing patterns develop, which is good. But watch this. What's going to happen here? That's going to be 0. And this is going to be 0. And you agree that this x will be gone and this will reduce to 1.
Yeah.
So what's in the top? Everybody sees 0 minus 6 gives you negative 6? Yeah, it's negative 6 times x in the top. Negative 6 times x. So am I plugging in a positive large number or a negative large number for x? So I get negative 6 times a large negative number because it's headed towards negative infinity. What's that going to produce? Positive infinity. Do you see how you have to be careful?
Yeah.
Okay, and that's how you can see. Good job. Flip it over. Okay, we'll show our work here. Okay, first, before we show it, can somebody make a prediction based off the shape of the graph? Negative infinity, because it's an upside down parabola, and so you know that both outputs would give you negative infinity. Let's confirm that. What do I factor out? X squared. And what are you left with? Minus 2 over x minus 3. Okay, good. So, what happens? 0, 0. Good. Negative 3 times x squared, or a big, large negative number squared, right? So a lot of people see this, and they say, oh, well, I'm going to square a large negative number, so it's going to be positive infinity. No, because you have to have 0 times negative 3. So this will produce a positive times a negative will be negative infinity. Notice how ahead of time we thought of the graph to confirm our answer. I need to see your work, but think about the graph to confirm the answer. Okay, so let's get to the nice part. You guys learned that in this situation right here, what's bigger, the numerator or the denominator? Denominator, so what's it going to go towards? Yep, it's going to go towards 0, okay? So you were right, that one goes to 0. Again, tell me why. Numerator is bigger than the denominator. Good. Let's look at this one. What's bigger, the numerator or the denominator? What's bigger, the numerator or the denominator? They're about the same, aren't they? I mean, they're kind of the same. And what I'm going to show you how you can kind of determine these things a little bit more quickly. But I'm going to factor what out of the top? I'm going to factor an x out of the top. When you factor x out, what are you left with? 4 minus 1 over x. And I'm going to factor an x out of the bottom. And what are you left with? Okay, so I remember seeing this type of problem exist on an AP exam, and I was able to see the answer just like that. And I'll show you what I look at in this situation. I look at the largest term in the numerator, and it's 4x. I look at the largest term in the denominator, it's negative 6x, and I divide them, and I get negative 2/3. I know that that's going to be the answer. Let's see how it works out. What's x over x? 1. What is 1 over x going to go to as x goes to infinity? 0. How about here? What are you left with in the top? What in the bottom? Which gives you? Isn't that nice? There you go. This one's a little bit different, okay? So this is going to be a 2-day lesson. We would like to go to this part tomorrow, but we'd like to get through some of these today and give you guys some time to work then tomorrow. What's different about this example? There's a square root. And so it looks really complicated. We're going to make it easy, and I'll write out my steps. Sometimes people get lost here, but we'll write out the steps. What do you think you factor out of the top? An x squared. Everybody agree? So if I factor out an x squared, watch as I write this. I'm going to write x squared times 5 plus 2 over x squared. Okay? Now, what do you factor out of the bottom? X. And you're left with? Good. Now, as we look at that, notice how this x squared sits underneath the square root. I would like to move it on the outside. What is the square root of x squared? So I can move it out here as an x then. Okay? So, what happens? These divide to 1. What happens to the 2 over x squared and the 1 over x? Those go to 0, and you're left with what's in the top? Square root of 5. In the bottom? 7. Excellent. Yep. Steve, you can do something similar to the next one. Go, try the next one on your own. Okay. Yep, that was really good. Did you start with this?
I took out a 2x.
Okay, I see why you took out the 2. That's okay. I'm going to leave the 2. I would encourage you to just factor out the variables and not the numbers. You can do it both ways, but I do think this makes it a little bit easier. What do you get if you put the x to the 4th out in front? X squared, okay? So, what's going to divide off? X squared over x squared divides off, and the 6 over the x to the 4th makes 0. So you have 8 over the root of 2. And can't leave the root of 2 in the denominator, so you get 8 roots of 2 over 2.
Divide it 4
roots of 2. Good. Yes. So I just did that for the AP exam. If you see the AP exam, then you could leave it. In my class, don't ever do it. Okay. We'll just do we'll save this one for the end, but we'll get through these. And like I said, we have a second day on this tomorrow, so you guys will have plenty of time to work. What do you want to factor out of here?
X squared.
So let's go limit as x goes to infinity of 2 times the root of, I factor out an x to the 6. Thank you, not an x squared, but an x to the 6. And what are you left with? We're left with 1 over x to the 4th plus 1. Okay? Minus 3x cubed. doesn't really look very good right now. Could I move this x to the 6th out front? And what does it become? Good. So limit as x goes to infinity of 2x cubed times the root of 1 over x to the 4th plus 1 minus 3x cubed. Now, what I'd like to show you is that we can actually take out a second factor. What factor could you take out now? X to the 3rd. So you have the limit as x goes to infinity of, I take out an x to the 3rd, and you're left with what? 2 roots of 1 over x to the 4th plus 1 minus 3. Now I feel comfortable dealing with this problem, because what's going to happen to 1 over x to the 4th? It's going to go to 0. And what's the square root of 1? Times 2? 2. 2 minus 3 is? Negative 1. So you end up with a negative x cubed. What's going to happen if you plug in a large number there and cube it? It's going to become large, and then you attach the negative, so our final answer is? Good, negative infinity. Okay, last two examples. There are no algebraic arguments here. Let's think of a graphical piece. What does the graph of negative 3 sin of x look like? Where does it start? Starts in the middle? Does it start by going up or down? Man, you guys learned a lot last year. Good job. So does this ever hone in on one value? So therefore the limit does not exist. Let's think about this graph right there. Cosine of 5x. Starts at the top. And this one is actually more condensed together because of the 5. It repeats itself more often. But does it ever hone in on one value? So therefore this limit does not exist. And that's where we'll pick up with that one then tomorrow. So you're not going to get an assignment today, assignment tomorrow. You'll get one assignment between the 2 days. You can start working tonight, tomorrow. Tomorrow you're going to have a lot of time to work after we finish that off. I don't know what we're going to do about the test. So for people who weren't here, there's no way we'll be ready to test on Tuesday. So I said, how about Wednesday? Sounds like a lot of people are gone for the musical. So, yep. So I really don't know what to do, and I won't be able to accommodate everybody, so I'll just be making a decision.